In 1.3 models and applications, we want to get a couple things across, mainly two important points. The first point is to be able to manipulate and solve an equation for any specified variable. And the second point is that we want to be able to come up with our own equations based on some kind of description or some kind of problem that is presented to us. The first thing that we want to talk about is solve a formula for a variable. And when we see these directions, we want to first target out what variable it is that we're solving for, right? And what it means is that that variable must be isolated on one side of the equal sign, right? So that variable equals some other things. So for example, we'll have this formula here. It's a perimeter equation. So P is equals to 2W plus 2L, right? So that's an equation, and the directions say to solve for W. Well, let's go ahead and do that. So P is equals 2W plus 2L, and we are solving for this variable by itself, right? So the first thing that we want to do is move everything else that has nothing to do with W to the other side of the equation, right? In this case, it's going to be the 2L. So we'll have P minus 2L equals 2W. Now we want to have W by itself. We need to get rid of the number that's being multiplied to it. So divide both sides by 2. Then we'll have P minus 2L divided by 2 is equal to W. And we have successfully solved that equation for W. Okay. Next, we want to solve the following formula for the variable C. So the previous problem was somewhat basic, and we only had to do division and subtraction of some terms in order to get it simplified. Here, however, we see something different. So we have the formula P is equals to C plus MC. So we're solving for C, but notice that it happens in several terms, two terms specifically. So we want it to happen only once, right? We don't want to see multiples of the same variable if it is what we're solving for. So how do we combine it or write it as once? So what we have to do is do factoring. So P is equals to, we're going to factor out what is common, and in this case it's the variable C. So we're going to factor out C, and we're going to be left with 1 plus M, right? C times 1 is C, and C times M is MC or CM. Whenever we rewrite something, which is what we just did, it should be equal to what's before it. Okay? They don't look the same, but they are still the same expression, so keep that in mind. And now that we factor out the C with only one occurrence of it, we can now simplify a little more. And so we're going to say P, well, we don't want anything to be with the C because we want C by itself. So we need to divide by everything that's multiplying to C. So we'll have P divided by 1 plus M is equals to C. And we have successfully solved for C. The only difficult part could have been the factoring, right? Everything else should be comfortable steps. For part 2, or the second objective, is that we want to solve problems with linear equations. Okay. The first thing that we want to do is read the problem several times before you can state it in your own words. You want to write down what is given and the problem that you're looking for. You know, what is the problem asking for? So then you want to assign some variable names. You know, X should represent the unknowns in the problem. Okay. If necessary, write expressions for any other unknown quantities in the problem in terms of X. So you want to define things in terms of X, or define them depending upon the unknown. Then you want to write an equation in X that models the verbal conditions of the problem. Right? You want to recreate mathematically whatever is being given to you in the problem, or use the information from the problem to create an equation. Then you want to solve the equation that you just created and answer the problem's question, right? Last, you want to check the solution in the original wording of the problem, right? It has to make sense in the original problem, in the words of the original problem. This is an example of a type of problem that you can expect. So you need to rent a rug cleaner. Company A will rent the machine you need for $22 plus $6 per hour. Company B will rent the same machine for $28 plus $4 per hour. After how many hours of use will the total amount spent at each company be the same? What will be the total amount spent at each company? So several things here going on. At least we can begin by stating that we have company A and we have company B, right? There's two companies, so at least let's split the information down that way. Now, how can we define some variables? So you can say that C is the cost, right? How much will it cost you to rent a machine overall, right? And so cost will be just an equation of which company, you know, the conditions of each company, and also time, right? And when I mean which company, I mean the details. And then it's got to be related to time, right? Because if you take a long time, then you're going to pay more. If you do it quickly, you're going to pay less, right? That's the idea. So kind of just a rough sketch of like what the equation is going to look like for us. So let me take that out of there so that we can use that space to actually write the equation or the conditions, right? So cost, and we'll say T is time. So for company A, the overall cost is going to be equal to $6 per time. We can make it better. Just say H for hour, so that it makes more sense. And so those are multiplied because for every hour that you use that machine, you're going to pay $6, right? And the $22 is a flat fee. So if you go with company A and you use the machine for 0 hours, you pay $22, period. If you use it for 1 hour, it's 1 times 6 plus 22, and so on. So the same idea goes with company B. We're going to use C for the cost and H for the amount of hours that we use this machine. Company B is renting the same machine for $4 per hour with a flat fee of $28. So again, if you rent a machine from them and you use it for 0 hours, you got to pay $28. So we're trying to figure out here many things. First, the equations. This is probably one of the most difficult things to do in this type of problems, because nobody tells you whether the equation is right or not, right? You gotta have some sense as to what you're doing is correct. And so now we look back and try to say, okay, yes, this describes what is being given to me in the problem. Now, what is it asking for? First question is, after how many hours of use will the total spent at each company be the same? So it's saying, after how long will the cost be the same? So, part A, or part 1, question 1, when or after how much time, after how long will the cost be equal for A and B? So here's where we kind of need to think about it. Cost equal. So the value of C is going to be the same for both. So what we can do is set them equal to each other. Company A equals company B. And then now we solve for H. We're going to figure out after how many hours do they equal each other. So solve for H. It's the only variable that we have there. Is what's common to both of them. So we'll have 6H equals to 4H plus 28 minus 22 is 6. And then we'll move the 4H to the left. And we have 2H equals 6. And divide both sides by 2. And we get H equals 3. So what does that mean? So after using the machine for 3 hours, the cost is the same for both companies, right? So if you know that your rug is going to take 3 hours to clean, it doesn't matter which company you go with. because they're both going to cost you the same at 3 hours. So that was part one of the problem, or question number one. Question number two says, what will be the total spent at each company? So here we just have to plug in 3. So H equals to 3 into either one of the companies, right? A or B. Since they equal the same at the value H3, then we just have to plug it into one of them. So the cost is going to be equals to 6 times 3 plus 22. So 18 plus 22. 18 and 22 comes out to be 40. So the cost to rent the machine for 3 hours is $40 in company A and B. Okay, so these problems are going to require a lot of practice, like reading the problem and then being able to come up with an equation that describes the problem, and at the end making sense of what you did, trying to see if it actually answers the question that the problem was originally asking. Okay, I believe that's everything for this video. Thank you for watching.